This week, it's all about the KRACK, a new Wi-Fi flaw, and the ROCA, a new attack against crypto. I guess it's a KRACK ROCA. Google removes more plugins, getting cash from ATMs, Equifax again and again. Adobe patches some more Flash. Don Pezet from ITProTV will join me for expert commentary today, and we'll probably talk more about KRACK and ROCA. So all that and more on this episode of Hack Naked News. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show that brings you the security news each week. And despite popular belief, we do wear pants. It's Hack Naked News.
Most of the organizations I work with, they have
released. Yes, you read it.
Actually do
the original Linux Kernel Security with Linux.
So I hope everybody has their resistance built up.
Brought to you by. Make sure your team is prepared to fight off the latest cybersecurity threat. ITProTV is the resource to keep you and your IT team skills up to date. You can stream ITProTV's courses live and on demand worldwide, so there's no need to send staff to off-site training. Their team solution provides access to a supervisor portal for full control over your team's training schedule and group analytics. Go to ITPro.tv/hacknaked and use the code HN30 to try it free for 7 days and receive 30% off your monthly membership for the lifetime of your active subscription. To learn more about ITProTV's team solution, sign up for a free demo of their supervisor portal. Do you have a website, an external presence, employees, an office? Any of these things can be compromised and attacked. How are you defending these assets? Have you penetration tested these public assets? Start 2017 by taking a proactive approach to securing your vulnerable areas. Black Hills Information Security has been helping companies find their weaknesses since 2008. Email consulting@blackhillsinfosec.com and see how they can help you sleep better at night. Welcome, everyone, to Hack Naked News. I'm your host, Paul Asadorian. It's Tuesday, October 17th, 2017. We got a packed show for you today. But first, make sure you visit our fine friends at itpro.tv/hacknaked. Use the discount code HN30. Sign up for that supervisor portal where you and your coworkers can enjoy training from the fine folks at ITProTV. So make sure you check that out. I am doing Paul's webcast on October 25th from 3 to 4 p.m. I'm assuming that's everything you need to know about security I learned from watching Kung Fu movies will make its debut. Look at that. I'm the Fu Manchu person. That's wonderful. So I've been giving that talk this year, and I'm going to give it as a webcast for those who may not have caught it this year on the conference circuit, as we'll call it. So it's a lot of fun. It talks about training, how to learn information security, and some of the other parallels between things that happen in Kung Fu movies and information security. So make sure you check that out. I think it's securityweekly.com/Kung Fu. Is that right? securityweekly.com/Kung Fu is actually a link that works and will allow you to register for my webcast. And now, no shortage of security news this week. I linked to, in the show notes, wiki.securityweekly.com, the Brian Krebs article, What You Should Know About the KRACK Wi-Fi Security Weaknesses. Basically, a weakness has been found in the key exchange for WPA2 that could allow attackers to perform man-in-the-middle attacks. Let's review some of the facts, which we'll go into more details later on. But first off, an attacker has to be on the same Wi-Fi network as the victims or create the same Wi-Fi network as the victims to perform a man-in-the-middle attack. Not necessarily with a stronger signal than the legitimate APs, but within range and basically force the clients to change channels, which, as a lot of people have been posting about, which is not necessarily accurate, but it is part of the 802.11 protocol. The newly discovered flaws take advantage of the weaknesses in WPA2 itself, specifically the four-way handshake. Does not require knowledge of the pre-shared key and works regardless of the EAP type in WPA2 enterprise networks. Largely, this is an issue with client software, primarily on Linux and Android, who are the most vulnerable because they use WPA supplicant from the OpenBSD project. Wireless APs could detect this attack, so be on the lookout for new firmware for your access points and new software for all of your clients. Fear that many IoT devices that have wireless clients may be vulnerable and never receive updates. Apple and Microsoft products are vulnerable, but not to the extent as their Linux-based counterparts. Tune in to Paul's Security Weekly this Thursday evening for a full techie discussion with our resident wireless expert, Larry Pezet, who I spent time with on the phone this morning to make sure I had all my facts straight. So if I'm wrong, then it's probably still my fault. No shortage of security flaws this week. The smart cards and TPMs. If it wasn't enough to have a major wireless vulnerability, there's a crippling flaw in a widely used code library that has fatally undermined the security of millions of encryption keys used in a wide variety of applications. The weaknesses allow attackers to calculate the private portion of any vulnerable key using nothing more than the corresponding public portion. The attack has been dubbed ROCA and stands for Return of Coppersmith's Attack. Ultimately, the companies that created the keys and the implementation, their pseudo-random number generator didn't generate truly random numbers, according to the University of Surrey cryptography specialist, Professor Alan Woodward. We have our own specialist coming on Enterprise Security Weekly tomorrow, Richard Moulds from Whitewood Security, who's been on the show in the past talking about randomness and the lack thereof. So look forward to that. And in our expert commentary today, Don Pezet and I will talk specifically about those two vulnerabilities because they are significant. Google is busy removing more malicious Chrome extensions from the web store. Google scrambled this week to remove malicious Chrome extensions from end users' machines after the popular Twitter account disclosed the issue publicly. The incident ramped up again one day later when the developers were able to get two other shady plugins past Google's defenses before they were removed. It's starting to remind me of WordPress plugins, which is kind of scary. A very open platform for developing extensions to the Chrome web browser has been the source of a lot of malicious activity lately. Yet another Linux Kernel Privilege Escalation bug. That's right, security researchers have discovered a new escalation vulnerability in the Linux kernel that could allow a local attacker to execute code on affected systems with elevated privileges. Pretty much you can copy and paste that exact sentence into really any privilege escalation vulnerability on any platform. Just substitute Linux for Windows or OS X. It was discovered by Venus Tech AD Lab, Active Defense Lab researchers. It is vulnerability CVE 2017-15265. It's due to a use after free memory error in the Advanced Linux Sound Architecture, or ALSA, which really doesn't surprise me because that's a pretty crappy portion of Linux code anyway. Dangerous malware allows anyone to empty ATMs, and it's on sale. Usually, hackers exploit hardware and software vulnerabilities to hack ATMs and force them to spit out cash. But now, anyone can simply buy malware to steal millions in cash from ATMs. Hackers are selling ready-made ATM malware in an underground hacking forum that anybody can buy for around $5,000. Researchers at Kaspersky Lab made this discovery and dubbed it Cutlet Maker. And make sure you check out the link because there's some pretty awesome screenshots of that as well. Hopefully you can make a pretty good return on that investment. Not that we encourage cybercrime or theft in any capacity. That's just a joke. Please don't buy the malware and do that. That's not what we're saying. Equifax and TransUnion have been hit by a malicious JavaScript attack. As it turns out, the vulnerability was not the result of a new breach, but rather some malicious JavaScript code that was used for tracking website performance was installed and found to do malicious things. The same issue is apparently affecting TransUnion, the rival to Equifax, according to security firm Malwarebytes. I mean, they're just more picking more on the credit scoring industry, highlighting the lack of attention to security. And while this wasn't a flaw in their website, certainly security processes could have spotted this even sooner. Adobe patches 0 days used on government spying. More news from Kaspersky Lab. They've been busy lately. Say what you will about the controversies that have come out, but they've been busy uncovering new malware. The previous and vulnerabilities. So the unknown vulnerability, which has been actively used in the wild by Advanced Persistent Threat, APT Group, Black Oasis. Originally discovered by Kaspersky's Anton Ivanov, the flaw, CVE 2017-11292, is a critical type confusion vulnerability that could lead to code execution on Windows, Mac, Linux, and Chrome OS systems. With that, we're going to take a very short break, but first, a word from our sponsors and some expert commentary. Has your network been breached? Cybereason can help you answer this question. Cybereason products hunt for threats within your network and eliminate them in real time. To Cybereason, real time means within seconds. Founded by former military hackers who don't play by the rules, they've built this experience into their platform. Harness ingenuity and imagination, not just code, to defeat attackers. Cybereason, disrupt the adversary and let the hunt begin. Welcome back, everyone. We hope to see you at Providence HackerCon. Is an event co-hosted by Security Weekly and Roger Williams University. Myself, Doug White, Ron and Cindy Gula, Ben Jackson, a bunch of the Security Weekly crew will be there this Saturday, October 21st at the Providence Public Library. SecurityWeekly.com/ProvHackCon for those interested in getting our youth involved with cybersecurity should attend. Signal Sciences is doing a webcast with us. We're going to talk about the struggles in identifying vulnerabilities in modern web applications and some of the techniques that were developed by Zane Lackey and over time and now at Signal Sciences. He was previously at Etsy. It's Thursday, November 2nd. You can go to securityweekly.com/Signal Sciences. Don Pezet is here with us today, and we're talking about the KRACK and we're talking about the ROCA. Where do you want to start, Don?
Let's I can't tell you how many times a day people ask me to talk about KRACK, but we'll start with KRACK. We'll move into ROCA. I think ROCA is probably the more important of the two, although KRACK is what's getting all the press because of the widespread epidemic. Let's talk about that. Let's talk about KRACK and how it affects so many people, right? Because it's not a flaw in a particular piece of hardware or a flaw in a particular OS. It's a flaw in WPA2. And so really, when it comes to wireless, we can't use WEP because it's broken. Mm-hmm. We can't use WPA. WPA2 is really the generally accepted encryption protocol. And whether it's enterprise or personal, it's just as vulnerable. So this is a massive vulnerability.
Yeah, and I want a couple of things on that point. Recently, WPA2 was certified to be cryptographically sound after some time of analysis, and that was a fairly recent event, I'm told. Also, with respects to working on appreciated key or enterprise, the attack preys on the WPA2 four-way handshake, which happens after the authentication. So you've already authenticated with the key or with enterprise. There is some part of that process that gets seeded into the four-way handshake. So that's happening after that. So it doesn't matter how you're authenticating. It's that four-way handshake that happens afterwards. And it's one of those things that, not many realize. And I remember asking Larry and talking about this. It's funny, in 2005, Larry and I were in the same wireless course from SANS. It was actually the first time Josh Wright had taught his wireless hacking course at SANS. And Josh is the author of many tools for wireless attacks. And it was one of those questions where I was like, well, in a pre-shared key environment, everyone has the key. So why can't I just decrypt everyone else's traffic? And then Larry, reminded me, remember in 2005, Paul, you asked the same question in class and got a great answer, and I just forgot what that was. And that's because everyone basically gets a unique session encryption so that can't happen. And that's part of that four-way handshake. Did I get all that correct?
Yeah, yep. That's
at a high level
in a nutshell. Yeah. And, encryption is a two-way street, right? Both ends are involved in setting up that encrypted tunnel. And so either end can compromise it. In this case, the interesting part is that it is more the fault of the client. And I think that's important to stress because when this initially hit the news, what did everybody do? Everybody was like, oh, man, I've got to get an update from my access point.
Yeah.
And it's important. It can be fixed on the access point side, but it's more readily fixed on the client side. And I know for a lot of people out there, not just businesses, but really people at home really have to worry about it because, how many people have a Linksys wireless access point that hasn't had a firmware update in years? They don't get updates regularly. And I checked mine at home. My wireless access point at home is maybe 8 months old, and there's no update to resolve KRACK yet. And those vendors have been notified for quite a while. They were notified 2 months ago, right?
Yeah, I believe so. From what I understand is that the access point can be, there was multiple attacks released, multiple vectors and exploitation techniques that they released. Some of the lesser severe ones do involve compromising the access point. I'm still working my way through the paper to understand how some of those other attacks work. The most serious vulnerability is that one on the client. It primarily affects Linux and Android clients. And the difference there is the resetting of the nonce, which is, I want to say it's essentially the seed, but that's not correct either. It's the nonce that's used in the cryptographic handshake will be reliably set back to 0, making it easier to predict what the keys will be and redistribute the keys. And that's essentially what it is, a redistribution of the keys. So that makes Linux and Android more vulnerable because of the predictability of the resetting back to 0. Apple OS X and iOS, I believe both of their products, in addition to Windows, actually don't allow that rekey generation process to happen. However, they are still susceptible to some of the other attacks, which aren't necessarily full man in the middle, but could allow you to inject traffic into their streams and things of that nature. So there are multiple attacks that are covered in the research that is being presented in Black Hat Europe, I believe in December.
Yeah, and I thought it was really interesting that a lot of this stuff tracked back to the WPA supplicant from the OpenBSD team, because OpenBSD is one of the few operating systems out there that are designed with security first, right? Yeah. I mean, they went so many years without an exploit in their root or their basic install, and to see something like this come out of them, that's surprising. Nobody's perfect, and if this was Microsoft's fault, nobody would bat an eye, right? But when it comes from the OpenBSD team, that's where you go, wow, how didn't this get noticed?
And there's a lot of open source wireless driver implementations, I think less and less today, because largely we've transitioned to using the OpenBSD team's implementation because it's performance-wise and stability-wise. I remember having this conversation with Josh Wright years ago, going, dude, I'm banging my head against the wall. I can't get this stuff to work reliably, not just for attacks, but also to make my wireless drivers work on my Linux systems. And he remembered telling me that the OpenBSD folks were working towards a much more stable platform for that. And of course, that came to fruition. And then now we have these vulnerabilities. Wireless drivers are not an easy thing to write and interpret. And of course, the standard too, as we've already pointed out, different people have thought different things about interpretation of the standard and implemented things slightly differently, as always happens when we have these open standards. And one of the things that was made very clear, and people are getting the whole proximity thing kind of not entirely correct. People tend to point out that, well, you can be 200 plus miles away because that was the record. Those were a very, very finite set of conditions that were in play to make that connection work. Second of all, it doesn't require that you broadcast a stronger signal. You're basically tricking the client, not tricking, but you're telling the client to change channels. The legitimate use case to change channels is the access point, such as from Cisco, which you're probably familiar with some of the enterprise stuff, Don, in the consulting that you've done in the past, where it has intelligence. So if there's interference from an external source, like a microwave or whatever, or the environment change and there's a weaker signal, some kind of interference, it can detect interference and tell the clients to change the channel. And that's built into the 802.11 protocols. In this attack, they're just telling the client, hey, change the channel, and then intercepting the communication.
Yeah, and honestly, when this first happened, I started reading the initial information about it. I remembered an installation that I had done for a bank, and the bank was way behind on wireless. They just hadn't deployed wireless because they didn't trust it. They didn't want any potential compromise or people being able to get on the network from outside of the building, so they didn't do it. And I said, wireless is as secure as you make it. And WPA2, now this was years ago, probably 9 years ago, I said WPA2 is secure today, but there'll come a time when it isn't. Yep. And so what you do is you supplement. And with them, a lot of people will have a private network and a guest network. I said, hey, just have a guest network. And then when your employees are on the guest network, they can VPN in just like they would on any public network, right? It's the zero trust model that Google has, where you just VPN in no matter where you are. And by doing that, if somebody compromises WPA2's security, well, your data is still encrypted with the tunnel on top of that. You get double layers, the whole defense in-depth type solution. Right. It's easy to resolve if your people are trained to do that already. And we're kind of fortunate that this happened now when most websites have moved over to being encrypted with SSL or TLS. A lot of protocols are encrypted, but not everything is. And even simple traffic like DNS traffic can be intercepted and overridden with this type of attack, which makes it really dangerous.
Well, yeah,
so
and,
I think
it's a good
shows,
thing.
Oh, go ahead.
It's a good thing that the encryption protocols are perfectly secure as well, Don, as for that other layer of protection. Oh, crap.
Yeah, there are flaws there, right?
And a pretty big one, which was released, which was called ROCA. And I don't understand this one in as much detail as the wireless ones. Obviously, I've described I have somewhat of a history with the wireless, and I did a lot of wireless security research. But this one involves a crypto attack that basically you can derive the private key from the public key, which is bad, and also preys upon weaknesses in the ability to generate random numbers, which, Don, you've talked about on the show, and we have another expert lined up for tomorrow to speak on this topic as well.
Yeah, the whole idea of that private key, public key model is that you can give your public key out like crazy, right? You can post it on the internet. That's what the PGP servers were for, right? So that anybody could get your public key. And your private key was completely safe. And what ROCA does is it kind of shakes that industry by saying, wait a minute, here's a situation where your public key might not be safe. Now, I want to stress that. It might not. Not every key is vulnerable. And some of the articles that are out there, I think Ars Technica did a really good job because they specified how, like, the researchers found that it was a subset of keys that were vulnerable. And it all ties back to this one chip manufacturer, Infineon. And unfortunately, their chip is used in a lot of TPMs, trusted platform module. It's trusted. We trust that module to do work. But the whole point of their chip was that when you needed to generate a key pair, that you could generate it on the chip as opposed to generating it in CPU and memory where malware or other things might be able to get involved with it. UB keys, I'm looking over my shoulder because I've got one over here somewhere. UB keys have the same thing. You can generate your key right on the UB key instead of generating it on your own device. And I think one of their models, the UB key 4, was actually affected by this. And if you generated a key that way, then it may be susceptible. And one of the things that I did when I first heard about this is I had a key that I generated on a YubiKey 4. It was like one of those situations where I completely fell into the attack demographic. And they've stood up a website. Have you seen this yet, Paul?
I haven't,
the Key Chest. Actually, I think I can bring it up here. Let me flex my IT muscle. This is the keychest.net website. And they've got where you can paste in your public key, not your private key.
Don't put your private key in there.
Private key in the website. But you can paste your public key in here, and it can take a look at it to find out whether or not it actually is vulnerable. And so I can take, for example, let me see, I've got floating around here. This is a PGP key or a GPG key that I had generated using a YubiKey. I generated it on device, and I can paste it in here and get a chance to find out whether or not that is susceptible. And it's a real quick test, and it'll tell you. And so here's this key that I generated that is not susceptible, and that's because it's using primes that are considered secure. So we don't have to outright panic on this one. Not every key generated with an Infineon chip is vulnerable, but there are many that are. And the Ars Technica guys, or some of the researchers they were working with, actually put out some numbers. Let me throw these out here for facts, right? So if you had a 2048-bit key like mine that I just showed, that if it was susceptible to this attack, it could take 17 days, if you were on Amazon Web Services using their EC2 instances, 17 days at a cost of $40,000, and you could generate the private key. That was the worst case scenario. So you estimate really it'd be like half that price to calculate most keys out. But if it was only a 1024-bit key, it would only take 45 minutes and about $76, worst case scenario, to generate what that key is. And I remember when I generated my key, because back then the YubiKey software still defaulted to a 1024-bit key, and I specifically used the command line tag to say, no, I want 2048.
Right.
And I'm glad I did.
Glad you did. Yeah, it just raises the bar for attackers, and I think in general practice, having the larger key space is valuable. And like you point out with wireless, Don, there might not be an attack today, but there could be an attack in the future, and you can kind of build in some insurance to that. So awesome. Well, Don, thank you so much for appearing on Hack Naked News today. It was awesome talking about these very timely topics of news breaking this week. So thank you, everyone, for listening and watching. We'll see you next time.